Okay, so I want to finish that last example from our disk and washers notes. And we got this example F. Let R be the region bounded by the graphs. Set up an integral that can be used to find the volume of the solid generated if R is revolved about the given lines. So I've already graphed it. We had graphed it in the other video before, but you can see my region. I've got y equals square root of x in red, y equals 0 in blue, and x equals 4 in pink. So the green part shaded in is what I want to find the volume of. So I'm going to rotate it about these different lines. So in all of our other examples, we were spinning about the x or y axis. So now let's look at it and see, all right, what do we do when we're spinning about a line that's not the x or y axis? All right, so I copied in those magic note parts, and you can see that handwriting part. All right, so here we go. About the line x equal 4. All right, so first, you need to decide, are you a disk or are you a washer? Are you solid to that line? Well, yeah, if you look at it, you are solid to the line that x equal 4 right there. So this would be a disk, okay? All right, so I know I'm a disk. Okay, for a disk, we draw our slice perpendicular to the axis of rotation. So I'm going to draw my slice like that to draw it perpendicular to that pink line. And so if you extended it out and thought about it, it hits that y-axis. So this tells me that this is a dy. All right, so let's look at our formula. Volume equals pi. All right, integral. All right, you want those limits of integration. It's a dy, so get them off the y-axis. So that's going to be 0 to 2. Come off the y-axis. All right, and then we know we're a disk, and so it says right here, okay, the radius will be axis minus the graph if the axis is positive. I want to spin about a positive, x equal positive 4, so it's positive. So I want axis minus graph. I want my axis, which is 4, what I'm spinning around, minus my graph. Now remember, we can't put in the square root of x because I am a dy, so that's not going to work. So I have to make sure that I put in the other version. So I have it in red up here. If you solved it for x, you get y squared. And then it's the radius squared. So there is that set up. And all we had to do was set them up. We didn't have to integrate it. So now let's do about the line x equals 6. So that's about this yellow line. Okay. All right. Obviously, I can look and I see this gap in here. Clearly, I am not solid to the axis of rotation. So this is a washer. All right. And again, though, I would draw my slice perpendicular to the axis of rotation for a disk or a washer. So that's still a dy. I hit that y-axis if I were to extend it out. Alright, so volume equals pi integral, and again I'm going 0 to 2, and I know I'm a dy. Okay, but washer is r squared minus r squared. Okay, so now I'm going to do axis of rotation is positive, so I'm going to do this line right here. Okay, the capital R is axis minus the farthest away graph. Alright, so let's do our capital R. Alright, and it's axis, which is 6, minus the furthest away graph. So let me pick a different color so you can see it. Let's do orange. Okay. So I'm spinning about this line right here. Okay. So it's axis minus the furthest away graph. So if you look at it and you think about it, well, the furthest away graph is the red one. Okay. So that is that y squared. Okay. And then little r is axis minus the closest graph. So our axis again is 6, and if we looked at it, let me go back to that orange, okay, we got to think about the closest graph to that yellow line. Well, the closest graph is going to be the pink line, okay, which is 4. Okay, so there is that integral set up, okay. Alright, and then we'll keep going now about the line y equals 2. Alright, so let me see if I can do this really quick. Alright, to kind of a color over what we've got. Erase those slices in there. Okay. Alright, here we go. Alright, so about the line y equals 2. Alright, I don't even have it drawn in here. Let's do that. Alright, let's get this. Let's do gray. Okay. So here is the line y equals 2. Alright, and so if you want to spin about that, clearly you are not solid to the axis of rotation. So again, that's a washer. Alright, but this time we draw our slice this way because we have to draw it perpendicular to that. So now this tells me I'm a dx. Okay? So I know I'm a washer and I'm a dx. Alright, so volume equals pi. Integral. Alright, so I'm going to get my a and b, my limits of integration, off of the x-axis now, since I'm a dx, so it's where it starts here and where it stops right there, so that's going to be 0 to 4. Okay, and that's a 4. I got to do capital R squared minus little r squared, and I'm a dx. Okay, so make sure you only put x's in these parentheses, no y's. Alright, so capital R, okay, so again I'm spinning about a positive axis of rotation, so capital R is axis minus the farthest graph, so let's think about that. Let me get back to the orange. Alright, so you want to be the furthest end. Well, that's going to be the furthest end, the blue down here, and the red's going to be the closest end. You can see that if you draw that slice. It's real important that you draw that slice each time. So it's going to be axis, which is 2, minus the farthest away graph. Well, that's the blue line, which is 0, alright, squared, and then it is axis minus the closest graph, which is that square root of x. Okay. Alright, and then I wish I could move this toolbar at the bottom, but I don't really know how to do that, so we'll just fit it in. Alright, so about the line y equals negative 4. Let me go put that line in there. Let's find something we hadn't used. Alright, let's do light blue. So y equals negative 4 is going to be here. So now I want to spin about that. Okay, so again, drawing my slice perpendicular to it. That's a dx, and that's a washer. Alright, so washer. So volume equals pi. Alright, integral 0 to 4. Alright, and then I gotta get big R squared, little r squared, and a dx. Okay, but now, when I think about it, my axis of rotation is negative 4. So that's when I'm going to look at this note right here. Both capital R and little r are going to be the graph minus the axis if the axis of rotation is negative. Okay, so we want to do this time graph minus axis. Okay, so you want to do furthest away and then you want to do closest. So right, if I think about my axis of rotation, the furthest away graph is the red, and the closest graph is going to be the bottom one, which is the blue. Alright, so let's fill that in. Alright, so it is graph minus axis. So I want farthest away graph, which is square root of x, minus the axis, which is a negative 4. So if we did have to, keep on going and integrate this out, make sure you fix that double negative and change it to a positive. Alright, then it's the closest one, which is the blue, the dark blue, which is 0 minus the axis, which is a negative 4. So again, you would fix that axis of, you fix that double negative. Okay. Alright, so we just had to set these up, but we've, worked these out. Remember, if you got to square these, either, know how to square the first, multiply, double square the last, or write it twice and FOIL it, but make sure that you are good with these. Alright.